Hello and welcome to Polyplane.com. Today we're going to be talking about 3D patterns. In the past few months, I've been sprinkling in videos that have to do with 3D patterns. The first one was paneling tools, where you take a series of shapes and forms and you can array them along a surface to create a repeatable paneling set. And the other was the displacement plugin, which uses a black and white or grayscale image to create an emboss on your surface to create a repeatable texture, or perhaps you want to just texturize part of a model with actual geometry. This is another way to do it. One tool that I forgot to mention is height field, and I'm going to show you that really quick before we get into today's tutorial, which is about 3D patterns. So let me make a surface real quick here. And there was a comment on the displacement tutorial, and I just wanted to address this showing this tool. So here we have a surface. Say you want to affect your actual geometry versus just affecting the display mesh. So there's a command that's not really talked about too much. It's called height field. What I can do is I can take a grayscale image, much like with the displacement plugin, and I select it. It's going to ask me how to sample, and we're just going to crank this up to like 100 by 100 and a height factor of 5. Actually, we'll make that about 3. And interpolate the surface through the samples. Click OK. And you can see what it's done. Using this image, it's actually created geometry based off of that grayscale image. Now, because I used 100 by 100 samples, that means that's 100 in the X and 100 in Y. Using the grayscale. Now, what I can do is, if say that height was too extreme, I could just scale 1D and get it down to something a little more reasonable. And it's actually a pretty effective way of creating geometry rather quickly, just using an image. Now, this is to replace the displacement version of that, which would directly affect the mesh. So your surface would still look like this, but the display mesh would look all embossed. So that's something I wanted to talk about. Now we can start talking about 3D patterns. Patterns are just repetitions in space, and you're defining the dimensions typically with an X and a Y. But you can also do it with the Z axis as well, so you can have things that repeat themselves in 3 dimensions versus 2. But there's a basic rule of thumb. We're going to be discussing hexagonal patterns and sort of checkered patterns, just because you can talk about spherical, triangular, and we could go on, but I just want you to get a sense of the basics. I have this set of lines here. Each line is individual, and this is sort of a basic way to set up a 2D pattern. So you could take it and make it look like this, where you have alternating black and white squares. But say you wanted to do something where it tiles in a different way than just a checker. Well, there's a couple of rules that you got to follow. One, whatever your opposing side is, you have to move it equal distant so that these now nest. So if I were to take this and move it and copy it over, it would nest perfectly into itself. Okay, so this rule actually applies in all the directions. So if I go up this way, I got to go up with that one, and if I go down with this one, I got to go down with this one. And you can start to see what's happening here. In order to make a pattern, essentially the outside edges have to obey their partners on their opposite sides. There's all sorts of fancy equations for this, but that's essentially the basics of what it is. Now, this is if you don't want it to overlap itself. And this works really well with square patterns. We're going to array this really quick here to here, and that'll make it nest into itself. So it's going to create this sort of pattern when you have that sort of repetition, and you can see it kind of staggers up. So essentially the basic rule is, if you do something to one side of the pattern, like this south edge here, you have to do it to the north edge to make it all work. And this can happen diagonally, or it can happen, to one of the 4 sides of the outer boundary. Now, the cool thing about some patterns, like say we've got this honeycomb pattern here, is that it can nest into itself. You can repeat the pattern in a more almost, I don't want to say organic way, but it is a little more organic than just simply cubic. For things that follow a more hexagon-shaped pattern, this is essentially the base, your most basic set. So whatever you do in these boundaries, so if I were to explode this I could actually get rid of these cross sections here and join this back together. This pattern is going to work out really well for nesting into itself, and you can repeat whatever you want. Now, the last thing I want to talk about before we get into the 3D patterns is that with something where you have a really basic pattern, so you can see that this is the basic repeat of this pattern. What's interesting about it is, and I don't want to get too much into the math, but essentially this is a fractal, so this is the same as its bigger shape. So I could repeat this outward as well. And that's a little abstract, I know, but I just want you to see that with the cool thing about checkerboard patterns is that they can be repeated very easily. So this is like very basic pattern where it's on or off and alternating in rows and columns. Anyway, let's get to the fun stuff here. With 3D patterns, you have to consider one last thing, and that is, do you want the 3D pattern to overlap its neighbor? And if so, anything you do in one set, you have to accommodate that in the next set. So let's take a look at this grid pattern, because this is going to be the most basic way to describe this. If you want to do something and you want it to repeat over and over again, and you use this as sort of your basic cell, you can have whatever you want to have happen in this cell. Now the cool thing about this even further than that is that because this is the same as this, we can actually just delete these and work with one cell and get the same result. So now we're all already reduced to one surface. So what I want to have happen in this cell is I'm going to put a sphere in here right about there, and I think I'm going to put a sphere here, and you'll see what I'm doing in a second. The surface acts as sort of a guideline of where I want my pattern to go. Let's say we'll project a curve, move that up and project, and then I'm going to split this. Let's extrude this. And remember, this is our basic tile. That means that this is going to eventually penetrate this again. So what we can do is actually trim back everything we've got so far. So I'm going to use this as a trim. Let's just get rid of that, get rid of that. It might actually be, because this shape is here, that means that it's going to repeat itself on the other side. That means that this form is going to have to move up as well to accommodate for that. And otherwise you're going to have some funky stuff happening. We'll do that. Let's use this as a trim. You could keep the bottom side of stuff and have it work just fine, but for what we're doing right now, we don't want to mess with it too much. And then let's have some sort of cool squiggly line that comes through like this, and then as a pipe, and trim it back. Okay, so that's doing that. Let's use this as a trim for our surface. We'll join these together, fill at the edge at 0.125 or something within that scale. And let's clean this up a little bit. Okay, we're getting somewhere here. And I think we can actually, at this point, join this together and then trim back the shell. So essentially what I'm doing is I'm making sure that everything is going to repeat perfectly. So if I were to take this now and move it over, obviously that's not going to work. But what would work is if I were to go like that and go like that and then that, and you can see what's happening here. We've got a pretty cool, freaky, weird, like H.R. Giger sort of tile thing going on where everything is tiling and repeating perfectly. So it's a matter of just remembering that whatever you're going to do on one side, you have to do on its opposite side unless you're going to mirror it over like we've done here. So if I were to look at what the basic cell, like one cell of what this pattern is right now, I would probably say that it starts here and ends here, and then everything added to that is just gravy. So we'll trim back all this. Okay, so you can take that back, and what you're going to be left with is your base tile. Now if I array this 3 by 3, and we'll make a unit cell the same size as its as its overall shape. What you're left with is this cool funky tile. Let's take this and turn on render. And it's kind of a weird sort of almost Art Deco-y sort of thing, but this is a cool technique for making repeatable patterns. I mean, this could be easily like a ceiling tile or some sort of funky thing, but essentially it's all about distilling down what your single cell is and then figuring out how you want to tile it. Do you want it to mirror over and over again, or do you want it to kind of nest within itself like in a hexagonal array? So it's something to consider for making 3D patterns. And I think that the cool thing about this is you could actually take your original pattern and make it into a block instance and then tile it, because that way you could update one component of it and then relink it to itself in the pattern, and the whole pattern will update. That is a fun way to make 3D patterns and create repeatable tiles. And then you can obviously go back and trim parts away if you want to make something that's a little bit more asymmetric but has that uniform texture. We'll kind of come through here like this. We'll join all those, make sure they are all linked together, and then use this and trim it back. You can easily trim away your pattern and then do whatever you want to have it join up to, like, I don't know, a wall detail, or maybe this is a trim line on a car and this is some sort of interior floorboard for extra grippiness, or I don't know. That's essentially the basic way you would go about making a tile. Now this piping that I did here, that's pretty simple as well, as far as making sure that it starts at one end and ends at the other. You'll get some cool funky shapes out of that, especially if you're going to mirror them and then array them to create one uniform tile. So alright guys, thanks so much for watching. Have a great day.